Draw these two vectors. This is vector A and this is vector B. So vector A and B are non-zero vectors and they are pointing in different directions. Okay. Let vector A be another vector which is in the same plane. See, we can extend these two vectors, we can join these two vectors, है ना? जैसे अगर हम इसको extend करते हैं तो ये यहाँ कहीं आएगा तो ये यहाँ कहीं आएगा, right? See, we have extended the vector, so you can see we have increased the magnitude of the vectors, given vectors. We had vector A and vector B, है ना? इनको join करने के लिए we have increased the magnitude of the vectors. So let's say that we have multiplied this vector A by lambda and vector B by mu. Okay. Now you can see these two vectors are in the same order. Tip of the first vector is coinciding with the starting point of the second vector. So which law of vector addition should we apply here? It's triangle law of vector addition. So we'll apply triangle law of vector addition, and this vector is starts from here, ends at here. This vector is the resultant vector of these two vectors, right? So let vector A be the resultant of these two vectors. Now, because this is the resultant vector, and how do we write resultant vector? If we have two vectors, this is one vector, this is another vector, right? This is vector P and this is vector Q. Then how do we write resultant of these two vectors? As vector P plus vector Q. So here also we can write the resultant of these two vectors as vector A, and it is equal to lambda vector A plus mu vector B. Write this, please. See, your topic is resolution of vectors. Resolution of vectors means we are splitting the vectors. ठीक है? अब split करते हैं vectors को, क्यों split करते हैं? और जब vectors split होते हैं तो वो same effect produce करते हैं as is produced by the given vector. So if you are saying that vector A is the resultant vector, so effect produced by vector A is same as the combined effect produced by these two vectors. Are you getting what I am saying? ये अकेला वेक्टर A वो इफेक्ट प्रोड्यूस करेगा जितना ये दोनों वेक्टर्स का एडिशन, कंबाइंड इफेक्ट, कंबाइंड होके ये दोनों वेक्टर्स जितना ये कंबाइंड होके इफेक्ट प्रोड्यूस कर रहे हैं, ये वेक्टर A अकेला उतना इफेक्ट प्रोड्यूस करेगा. ठीक है? क्लियर है? Should I clear the screen? This is x-axis, origin, and this is y-axis. So we have a vector A, and this vector A makes an angle theta with the x-axis. ठीक है? See, we can resolve this vector into two components. We can also resolve this vector into three components. ठीक है? तो जो परपेंडिकुलर कंपोनेंट्स में हम रिजॉल्व करते हैं, जैसे एक्स एक्सिस के लॉन्ग या वाई एक्सिस के लॉन्ग, उसको हम रेक्टेंगुलर कंपोनेंट्स, तो कोई डाउट नहीं है ना? तो जो अब जो वेक्टर ये वाला जो वेक्टर है, अगर इस वेक्टर एक को हमने रिजॉल्व किया एक्स एक्सिस के अलॉन्ग और वाई एक्सिस के, तो जो एक्स एक्सिस के अलॉन्ग है वी कॉल दैट वेक्टर एज ए एक्स, एंड जो वाई एक्सिस के अलॉन्ग है फॉर दिस वेक्टर वी कैन राइट ए वाई. Okay, along x-axis unit vector is represented by I cap, along y-axis unit vector is represented by j cap. So we can write vector a as, क्योंकि इसमें पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन लगाओगे, है ना. So this is the resultant vector of these two vectors. So we can write vector a as ax vector plus ay vector. Or a vector can be written as magnitude and its direction. Similarly, we can write for vector ay its magnitude and direction. Okay. Now, what is the angle between these two vectors? It's 90 degree. So we can write the resultant vector, magnitude of the resultant vector is a, and it is equal to square root of ax square plus ay square plus 2 ax ay cos 90 degree. Cos 90 degree is, so it's ax square plus ay square root. Okay, and how do we write the, see this angle is the angle between the resultant vector and the one of the vectors, है ना. वहां पे क्या था, वहां पे ये वेक्टर r था जो लास्ट क्लास में हमने किया था. दिस वाज वेक्टर a and this was vector b, and the angle between the resultant vector and vector a was alpha. ये क्या था, so tan alpha is equal to, and this was theta, no, tan alpha is equal to b sin theta upon a plus b cos. ये क्या था हमने, here for alpha we have, in place of alpha we have theta, and in place of theta we have 90 degree. Okay, so wherever we have theta we'll write alpha, and where we have yeah, theta जहाँ पे है वहाँ alpha, जहाँ alpha है वहाँ theta लिखेंगे, और जहाँ पे theta है वहाँ 90 degree लिखेंगे. ठीक है, so angle between the resultant vector and one of the vectors is tan theta. It is equal to b. B is ay na, b is ay, write ay sine 90 degree divided by ax plus ay cos 90 degree. Cos 90 degree is 0, sin 90 degree is 1, so we can write ay by ax. Okay, clear? We कर रहे हैं बेटा class last. Okay, now join this. See, this is theta. अगर ये ay है ना, let this be m n and this be p. So your ये क्या हो रहा है, on is equal to mp है, ये a है, ये theta है, and mp can be written as op sin or cos, op sin theta. OP is A, so it's A sin theta. ON is AY. Similarly, we can write for OM. OM is OP cos theta. OP is A. It's A cos theta. So this is AX. AX is equal to A cos theta. So we can also write this vector A as, for Ax we will write A cos theta I cap. For Ay we will write A sin theta. So it's A sin theta j cap. ठीक है? Or you can find the angle also by dividing these two, है ना? By dividing A sin theta and A cos theta. So Ay by Ax. Ay is A sin theta and Ax is A cos theta. You can find the angle. It's tan theta. So tan theta is equal to Ay by Ax. Also, if we let this be 1 and this be 2, 1 square plus 2 square gives, first take the square, it's A square cos square theta is equal to Ax square ho jayega, hai na? We'll write on the other side. And here we have A square sin square theta. We are adding with first we are squaring and then we are adding. It's Ay square. So we can write Ax square plus Ay square is equal to, take A square common outside, in the bracket we'll have cos square theta plus sin square theta, it is 1. ऐसे भी derive कर सकते हैं, ठीक है? ये आपने कैसे किया? ये जो आपने जो ऊपर वाला डेरिवेशन है ये कैसे किया? ये आपने मैग्नीट्यूड एंड डायरेक्शन ऑफ आर जो हमने फाइंड किया था ट्रायंगल लॉ ऑफ वेक्टर एडिशन और पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन में, उससे फाइंड किया। और ये वाला जो सेक्शन है ये कैसे डिवाइड किया आपने? सिंपल पाइथागोरस थ्योरम लगाई है, राइट एंगल ट्रायंगल का कॉन्सेप्ट लगाया, थोड़ी सी ट्रिगोनोमेट्री, है ना, और पाइथागोरस थ्योरम और राइट एंगल ट्रायंगल के कॉन्सेप्ट्स लगा के वी हैव सॉल्व्ड। तो ऐसे भी वही एक्सप्रेशन आ रहा है जो ऊपर आ रहा है, राइट? डिफरेंस तो नहीं है ना? So resolution of vectors into rectangular components. The given vector can be split up into 2 or more components such that the combined effect of these components is same as the original vector. If we have a vector R, if we have a vector R and we can get the, rectangular components. Components, vectors which are at right angles to each other are called the rectangular components by resolving it into 2 parts. Okay. So Rx and Ry. So Rx is the horizontal component and Ry is the vertical component. So now we can write Rx as R cos theta and Ry as R sin theta. Okay. So by the parallelogram law of vector addition, vector R is this Rx plus Ry. ये तो पता ही है हमें. So we can write this as Rx I cap, Ry j cap. अब क्या होगा इसके बाद कि cos theta पाइथागोरस थ्योरम अप्लाई करोगे, ठीक है? तो इट्स Rx by R, तो ये आपका Rx R cos theta हो जाता है और Ry आपका सिमिलरली R sin theta हो जाता है. This we had covered in the previous class. Okay, and when we square these two terms, 1 square and 2 square, then we get R square cos square theta plus R square sin square theta. वो 1 हो जाता है and आपका left hand side में you have Rx square plus Ry square. So we can write Rx square plus Ry square as this. Take R square common, थोड़ा शिफ्ट हो जाओ, प्रॉब्लम तो नहीं हो रही है मेरी वजह से? लैप पे रखा हुआ है, कंफर्टेबल, ठीक है? तो this is the final expression that we'll get. R square is equal to Rx square plus Ry square. ये क्या था लास्ट क्लास में, ठीक है? तो यहाँ से आपका R आ जाएगा स्क्वायर रूट ऑफ Rx square plus Ry square. Any doubt? अच्छा, इसके बाद we can also find direction of the resultant vector because the angle with the resultant vector makes with one of the vectors is theta. Okay, so we can simply divide these two expressions to get the angle. Okay, so 2 divided by 1 gives this. Ry by Rx, Ry is R sin theta and Rx is R cos theta. So sin theta upon cos theta is tan theta. So this is how we can find the angle between the resultant vector and one of the vectors, one of the given vectors that we have. Similarly, in 3 dimensions, we can write the resultant vector as r is equal to rx I cap, ry j cap, rz k cap. Okay, and magnitude of r can be written as your square root of rx square plus ry square plus rz square. This is how we can write the magnitude. Okay, please write this in your notebook. See, how do we find direction of a vector? Direction of vector कैसे find करते हैं और उसको किससे represent करते हैं? That's about the resultant vector. Any vector. Yes, I cap, j cap, k cap are the unit vectors which are along x, y, and z axis. What if we have a vector, a random vector, vector A, and we want to specify the direction of vector A? So we can, write a cap for that vector. A cap is the unit vector, and magnitude of a cap is 1 unit vector, and its direction is same as that of given vector. This is how we write. Okay. So a unit vector represents the direction of a given vector. Please write this in your notebook. A unit vector किसी भी वेक्टर का डायरेक्शन को रिप्रेजेंट करते हैं, किससे रिप्रेजेंट करते हैं? उसके यूनिट वेक्टर से रिप्रेजेंट करते हैं. ठीक है, यूनिट वेक्टर स्पेसिफाइज द डायरेक्शन ऑफ द गिवन वेक्टर. एंड what is a vector? How do we write a vector? A vector consists of magnitude and direction both. We can write a vector as vector A is equal to A. This A represents the magnitude and this A cap represents the unit vector along the direction of vector A. ठीक है, अब जो A cap है, direction of A cap is same as that of vector A. ठीक है, but it is of unit magnitude. Clear? So where vector A is the vector, A is the magnitude of vector A, and A cap is the direction of vector A. Done. So we can write unit vector as given vector upon magnitude of that vector. So unit vector can be written as vector upon magnitude of that vector, vector A by A. Any doubt in this? You have already done this. So there is one theorem, Lami's theorem. It says that if we have 3 coplanar forces, coplanar means which are acting on the same plane. If there are 3 forces which are acting on the same plane, acting at a point, are in equilibrium. When do we say that forces are in equilibrium? Forces are in equilibrium when net force is 0. Forces are said to be in equilibrium when net force is 0. Then each force is proportional to sine of the angle between other 2 forces. So look at this. So here you can see we have F1 at this point where all these lines are intersecting. At this point, F1 force is acting, F2 is acting, and F3 is acting. And we are assuming that all these 3 forces are acting at a point and these forces are in equilibrium. Okay, these forces are in equilibrium. Then each force is proportional to sine of the angle between other 2 forces. So if we take F1, the sine of the angle between other 2 forces are F2 and F3. And what is the angle between F2 and F3? It's alpha. So we'll take F1 and sine of the angle between other 2. Other 2 is F2 and F3. Other 2 is F2 and F3. So it's sine alpha is equal to F2 again, F2 upon sine of the angle between F3 and F1. It's sine beta. F3 upon sine of the angle between F1 and F2. It's sine gamma. Okay, so F1 upon sine alpha is equal to F2 upon sine beta is equal to F3 upon sine gamma. This is Lami's theorem. And similarly, we can write direction cosines L, M, and N of a vector. See, L, M, and N represents direction cosines. They are the cosines of the angles alpha, beta, and gamma, which a given vector makes with x-axis, y-axis, and z-axis respectively. देखो यहाँ. So we have this vector A. ठीक है. तो अब ये जो वेक्टर A है, हमने इसको एक we have assumed a coordinate axis. ठीक है. तो coordinate axis इसको locate करने के लिए. अब ये वेक्टर A, it is making an angle alpha with x-axis and it is making angle beta with y-axis and gamma with z-axis. Right? I cap, j cap, and k cap represent the unit vectors along the coordinate axis. ये पता है हमें. अब यहाँ देखो, ये वेक्टर A है. Look at this vector and look at this x-axis. Angle between vector A and x-axis is alpha. Angle between vector A and y-axis is beta. This angle is beta. Angle between vector A and z-axis is gamma. क्लियर है इतना. मतलब एक वेक्टर ए तीनों एक्सिस के साथ एंगल फॉर्म कर रहा है. एक्स के साथ अल्फा, वाई के साथ बीटा और जी एक्सिस के साथ गामा. राइट. सो विल टेक कोसाइन ऑफ द एंगल्स. कोसाइन ऑफ द एंगल्स मींस cos अल्फा, cos बीटा, cos गामा. They are called direction cosines. They are called direction cosines. Okay. So we can write L. See, L represents the direction cosine. So L is equal to cos alpha. It is ax by a. And m is equal to cos beta, it is ay by a, and n is equal to cos gamma, it is az by a. ठीक है. तो squaring and adding, when we square and add, then we get this. See, we write, instead of writing cos alpha, cos beta, cos gamma, we are writing Lm and N. मैं समझा देती हूँ. How do we write a vector? If we have a vector, how do we write a vector? Vector A. So vector A, along x-axis, we can write component of vector A as ax. Along y-axis, we can write component of vector A as ay. Sorry, it's not y-axis, it's z-axis. So along y-axis, we can write component of A as ay, and along z-axis, we can write component of A as az. Any doubt? So any vector A can be written as ax vector plus ay vector plus az vector. Yes, or we can write this vector as ax I cap plus ay j cap plus az k cap. We can write like this. Any doubt? Clear. Okay. Achha, suppose if instead of considering 3 axes, if we take 2 axes, x and y axis only, if we don't consider third axis, okay, then what? Suppose we have this as x axis and this is our y axis. Sorry. And this is my vector A. Okay. And this vector is making an angle alpha. Let's take alpha only because we have this angle alpha now. So let's take alpha. This vector is making an angle alpha with x-axis. So we can resolve this vector A into rectangular components, right? For this component, horizontal component, we can write ax and it is equal to a cos alpha. No? And for vertical component, we write ay and it is equal to a sin alpha. This is how we write. This is how we write. Okay. What if instead of writing like this, see this angle is alpha. So measurement of this angle would be, it's 90 minus alpha. No? So, अगर मैं ऐसे ना लिखूं, ठीक है, or what if I write ay as a sin a cos 90 डिग्री माइनस एल. क्योंकि हम क्या कर रहे हैं, हम जो बेस एंगल है उसका रिजल्टेंट जो आपका वेक्टर है, गिवन वेक्टर है, उसका बेस एंगल के साथ जो वो हॉरिजॉन्टल लाइन के साथ जो वो एंगल फॉर्म कर रहा है उसको हम कॉस लेते हैं और जो दूसरे वाली साइड होता है उसको हम साइन लेते हैं. दिस इज व्हाट वी डू. है ना, कि अगर ये कोई वेक्टर है और ये इस एक्स एक्सिस के साथ अगर अल्फा एंगल फॉर्म कर रहा है देन वी टेक यस, ठीक है, तो ये इसके साथ अल्फा फॉर्म कर रहा है, इसी के साथ फॉर्म कर रहा है ना, तो ठीक है, इसको हम कॉस अल्फा ले लेते हैं। और इसके साथ फॉर्म नहीं कर रहा है, इसके साथ फॉर्म नहीं कर रहा है अल्फा, है ना, तो इसको हम साइन अल्फा ले लेते हैं। यही असम्पशन है ना हमारी, हम ऐसे ही चल रहे हैं ना, कि जिसके साथ फॉर्म कर रहा है उसको कॉस लेना है और जिसके साथ फॉर्म नहीं कर रहा उसको साइन लेना है, ऐसे ही चलते हैं ना। बट अगर हम यहाँ का एंगल कंसिडर करें, यहाँ का एंगल 90 माइनस अल्फा है, जो ए वाई एक्सिस के साथ फॉर्म कर रहा है एंगल वो 90 माइनस अल्फा है, तो अगर हम वो ले लेते हैं तो क्या प्रॉब्लम है, तब हम कॉस ले लेंगे क्योंकि वो बेस के साथ फॉर्म कर रहा है ना। नहीं ले सकते क्या? क्या हम इसको ए कॉस 90 माइनस अल्फा नहीं लिख सकते? और क्या हम इसको ए साइन 90 माइनस अल्फा नहीं लिख सकते? वी कैन राइट, लिख सकते हैं, ठीक है ना। बस यही कॉन्सेप्ट है आपका कि इफ यू हैव दिस एंगल अल्फा, इफ दिस वेक्टर ए is making an angle alpha with x axis and with y axis it is making an angle beta, so this is our beta, this 90 minus alpha is our beta, ठीक है। So instead of writing, see we write like this na, because we have this vector a, so we write vector a as ax I cap and ay j cap, and in polar coordinates we write vector a as a cos theta I cap, a sin theta j cap. This is what we do. We have alpha here, so write alpha. Let's write alpha. क्या फर्क पड़ रहा है ना। तो यहाँ पे हम cos अल्फा आई कैप ले लेते हैं और यहाँ पे हम a sin अल्फा j कैप ले लेते हैं, ठीक है। तो अब क्या है, अब this, you know, if we take this ay, if we write this ay as a cos 90 degree minus alpha, this 90 degree minus alpha is beta, so we can write ay as a cos beta. So now we are writing this as a cos alpha I cap and a cos beta j cap. We are writing like this. So if we have two rectangular components, and it is very, you know, it is convenient to write the sine form. But for if we are considering three different axes, then it is more convenient to write in cos form. तो साइन थोड़ा सा, बिकॉज यहाँ पे साइन लोगे तो यहाँ क्या लोगे, तो फिर हम क्या करते हैं कि उस वेक्टर का हर एक्सिस के साथ जो बेस एंगल फॉर्म हो रहा है वो ले लेते हैं, अल्फा बीटा गामा, उनके कॉस ले लेते हैं, उनके कोसाइन ले लेते हैं, तो क्या प्रॉब्लम है, ठीक है। और जैसे हम टू कोऑर्डिनेट्स के लिए क्या करते हैं, वी राइट ए एज अंडर द स्क्वायर रूट ऑफ ए एक्स स्क्वायर प्लस ए वाई स्क्वायर, दिस इज व्हाट वी राइट, है ना। सो वी कैन राइट ए स्क्वायर एज ए एक्स स्क्वायर प्लस ए वाई स्क्वायर, दिस इज व्हाट वी डू, है ना। तो इन द सेम वे वी हैव रिटन फॉर 3D, we have three components now, so we have included this az square also. So जैसे आपका ये a square होता है ऐसे आपका ये भी a square है, तो उसमें भी कोई प्रॉब्लम नहीं है, राइट, नहीं है ना। अच्छा एक और चीज है, as we write ax is equal to a cos alpha, so can't we write cos alpha as ax upon a, कोई प्रॉब्लम है उसमें, नहीं है, ठीक है। तो ऐसे ही आपका cos alpha ax upon a हो गया, cos beta ay upon a हो गया और cos gamma az upon a हो गया। So when you square all these terms and add all these terms, then you get L square plus M square plus N square. Or we can write cos square alpha plus cos square beta plus cos square gamma. Or we can write AX square by A square plus AY square by A square plus AZ square by A square. So denominator is same. So we can simply add the numerators. And ये जो numerator है, ये क्या है? It is nothing but A square. You're getting 1. Any problem? Any doubt? Cos square alpha plus cos square beta plus cos square gamma is equal to 1, ठीक है। See, we know the identity na, cos square alpha plus sin square alpha is equal to 1. So in place of cos square alpha we can write 1 minus sin square alpha, and for cos square beta we can write 1 minus sin square beta. For this we can write 1 minus sin square gamma. We can write like this. Please do this. Okay, so cos square alpha can be written as 1 minus sin square alpha, cos square beta is 1 minus sin square beta, and cos square gamma is 1 minus sin square gamma. Gamma is equal to 1. So we have 1 plus 1 plus 1, 3 here. So 3 minus, in the bracket we will have sin square alpha plus sin square beta plus sin square gamma is equal to 1. Okay, so we'll get sin square alpha प्लस साइन स्क्वायर बीटा प्लस साइन स्क्वायर गामा इज इक्वल टू 3 minus 1. 3 minus 1 is, ठीक है, write this.